Hello everybody. Welcome to another video by NCache. Today I will demonstrate how you can use NCache in Azure Kubernetes Service, also known as AKS. AKS is a managed container service that is available on Microsoft Azure Public Cloud. It is built around application containers that are powered by Docker, while the orchestration and management services are provided by Kubernetes. And today I will show you step-by-step details for deployment and usage of NCache in this platform. Let's quickly get started with this. First of all, let's review NCache deployment in AKS. Here is a typical deployment of NCache in AKS. I'm showing a single Kubernetes cluster with different application deployments as well as NCache cluster deployment. I've got a Java web app using Docker image on different pods. I've also got a Java web service, again deployed on different pods. And these Java applications are using Java client of NCache to connect to my cache cluster. Similarly, I've got an ASP.NET Core web app deployed on different pods using Docker image. And these instances are using .NET Core installation of NCache to connect to my cache cluster. My cache cluster is also based on Docker image, which is Linux-based image of NCache, available on our website as well as on Docker Hub. And that's what I've used to create a cache cluster on different pods. Additionally, I've got this NCache remote monitoring gateway. That is a gateway for monitoring and management operations that are performed from outside this Kubernetes cluster to manage and monitor my cache cluster. And I've got this cache discovery service. This is a headless service, which is named as well. And that's where my clients connect. And that manages all the client to server communication with my cache cluster. I don't need to know about the IP address of pod 10, 11, and 12. Client application only connects to this discovery service, and that would in turn manage discovery and routing of these commands or these operations to underlying pods. I would show you step-by-step details on how to actually create this discovery service and remote monitoring gateway along with cache cluster and deployment of these client applications once we get to our hands-on portion. But for now, this is a typical deployment of NCache in AKS using a single Kubernetes cluster. Here are details on our demo environment setup. I'm using two NCache servers to host my cache cluster, and I'll be running two client applications to connect to this cache. I'm using Linux-based Docker image of NCache for this deployment, and it is represented with this tag, Enterprise Server Linux 5.0.1. And this tag needs to be part of your Docker pull command as well in order to use this image. I'm using NCache Enterprise 5.0 Service Pack 1 and .NET Core release of it that you can deploy on Windows as well as on Linux environments. But for deployment in AKS, I'm using Linux-based image for this release. I'm using a Java application, which is going to use Java client of NCache. And then I'm using one .NET Core application as well, which is using .NET Core client of NCache. Within these applications, I'll be using CRUD operations that would represent app data caching use case for my applications. First step is to deploy NCache servers in AKS. So let's quickly get started with that. Okay, I'm logged into Azure Management Portal, and that's where I'm going to get started with all the deployments. First thing that I need to do is to create a resource group. And after that, I would go ahead and with all the deployments, hit add, and I'm going to actually get started with this step. Keep everything simple. Review and create. Hit create, and that would go ahead and create a resource group where I would deploy my Kubernetes service. So if I refresh on this, after that we will go ahead and create our Kubernetes cluster, Kubernetes service. If I click on it, I should be able to go see all the deployments within this. It's empty at the moment. And next thing is that we need to create the Kubernetes. Right. And I can now create Kubernetes service. By the way, I can do this through Azure Cloud Shell as well, which is right here. And reconnect. Or I can use the management portal, which is convenient. So I'm going to pick my subscription, and then resource group needs to be AKS demo, the one that we recently have created. I'm going to name the Kubernetes cluster my AKS, and as you can see, it automatically pre-filled the DNS name as well. I'm going to pick US, Central US as my location. Kubernetes version needs to be specified. Now I'm going to go with default, but you can pick any that is desired. And rest, I would keep everything simple. For primary node pool, I need to specify the node size and count. So you can either pick the standard or you can change the size. This is where your Kubernetes service is actually going to be hosted, right? So you need to come up with right, choice for service with enough memory, CPU, and networking resources. It gives you many options to choose from within VM sizes, and then based on different parameters such as RAM, CPU, disk, and other parameters. So I'm going to pick B2MS because that's the minimum that I can use for this test. And node count is going to be 2 for me, but you can come up with any node count such as 2 or 3, and that's the number of servers where the Kubernetes cluster is going to be hosted. Right, so having gone through this, I'm going to choose review and create, and that would create my Kubernetes cluster. It would perform a bunch of validations in Microsoft Azure, but you can see different settings such as scale, authentication, networking. You can keep everything default or change as needed, and you can also see monitoring. And if you hit review and create, it would get started with the validation process. So after final validation is completed, I'm going to hit create. It would take 5 to 10 minutes to actually complete this in Microsoft Azure, but after that we should be able to get started with the deployments. As you can see, your deployment is underway. Once this is done, this would turn the status mark into green. So I need to pause this video at this point and come back once this is done. It's already done. As you can see, your deployment is completed after taking 5 to 10 minutes. And I can now go to resources. And based on this, I can see my AKS service, which is my AKS. There you go. Successfully created. If I click on it, I can see all the deployments details for this service, such as Kubernetes version, the API server address, and then its status is succeeded, and the location is what we have specified. So this has completed our Kubernetes service. Coming back to the deployment diagram, our Azure Kubernetes service is now created in Microsoft Azure, but it's empty at the moment. Next step is to go ahead with NCache server-side deployment to deploy our cache cluster. So let's see how to do that. All right, my AKS cluster is now configured and it's available to be used for deployments. We've used the Azure Management Portal, but for next step, for all the deployments, we'll use Azure Cloud Shell. And first thing that we need to do is point towards the AKS cluster within this shell. So for that, I would run AKS get credentials command. So within AKS is for Azure Kubernetes Service. Get credentials command allows me to bring the current context to my AKS, which is our AKS service, and within the AKS demo, that's the name of the resource group where this is created. So that would allow me to point towards my AKS Azure Kubernetes Service, and I can get started with the management and deployment operations. So first thing that we need to review is whether there are any existing deployments. So I would go ahead and run a command real quick, which is kubectl get pods, and that will give me the existing pods. So there are no resources found in default namespace. That suggests there are no deployments as yet, but we need to deploy NCache servers. And for that, I would bring the NCache YML file, and that's what I would use for NCache server-side deployment. So kind is chosen to be deployment. Name is, of course, NCache. So that's what I'll be referring going forward for all the server-side deployment of NCache within other services and within the client applications as well. The image that we're using is Linux-based Docker image of NCache, and I'm using 2 replicas. Essentially, we have 2 pods where NCache cluster is going to be deployed to start off, and then we can add more pods at a later stage. The Docker image, let's talk a little bit more about it. The Docker image that we're using is Linux 5.0.1 Docker image, which is available on our Logisoft Docker Hub page right here. We have a Docker pull command, which is by default going to fetch you a Windows image, but you can also use the Linux by using this tag right here, Enterprise Server Linux 5.0.1, and that would fetch you. And that's what I'm using right here as well. So let's go ahead and add this YML to get started with NCache server-side deployment. So I'm going to run kubectl create with /f and provide this YML file to get started with NCache server configuration and load NCache Linux-based image in our AKS cluster. There you go, NCache deployment is created. It's that simple. As part of the deployment, this has also opened some management and monitoring ports, 8250 and 8251. So all the pods would have these ports open for management and monitoring, and that too from outside this Kubernetes cluster as well. And then we also have the client port, which is port 9800, and that is main client to server communication port that our applications would use and connect to this cache cluster. At this point, our NCache server-side deployment in AKS is completed. We will create a discovery and management gateway next, and then we'll come back and review all these deployments at once. Now that our NCache server pods are successfully deployed in AKS, next step is to create a cache discovery service as well as a management gateway in AKS. And these services, the discovery service would allow my client applications to discover and connect and use underlying pods within the cache cluster that we'll create. And then our remote monitoring gateway would allow any system admins from outside this Kubernetes cluster to manage and monitor these pods for the cache cluster. So let's review all the steps here. Now, in order to create these services, I have this services.yml file right here that would allow me to create these services. So I'm creating two services, a gateway as well as a cache discovery service. The gateway is for monitoring and management, whereas discovery services for client to server communication for routing and discovery to the underlying pods within the cache cluster. So first service is our gateway service right here. The kind is chosen to be service, and it is mapping 8251 port to the underlying pods. And this is for outside world to actually be able to connect to the underlying pods for management and monitoring. And this is why I've chosen the type to be load balancer, and the app selector is NCache. And session affinity is a very important concept. We need to choose this to be client IP. That's a mandatory step, and that allows my connections to the underlying pods to be sticky. We're using web-based management tool to manage and monitor NCache pods. So we need, and that creates a session. So if first request goes to pod 1, it needs to be sticky to that pod so that session remains intact for subsequent calls as well. So you need to have session affinity bit set to client IP for this gateway service as a must. That's a mandatory step, and then you can get started with the deployment of this. Second service is a headless service for auto discovery of your cache server nodes for client to server communication. I have chosen the name to be cache server. Again, the kind of this is service. So it's again a service, a headless one. And what really makes it headless is the cluster IP, which is chosen to be none. So it does not have any IP. It just manages internal discovery and routing of client applications to make connections with NCache pods. And how it connects to NCache pods? With the help of the selector, which is NCache. And that's what we used for NCache deployment as well when we deployed NCache server pods. And in this, we essentially have mapping for this discovery service. We have a mapping of 8250 to underlying pods, 8251 mapping, and then 9800 for client to server communication. So we will go ahead and load this YML file, again using the same kubectl create command with /f, and we will deploy these two services in our AKS cluster. I think there's a typo. AKS configs /ncache, actually services.yml. If I hit enter on this, I should be able to see two services created. a gateway service and a cache server, which is an auto discovery service for NCache server parts. Now, if I quickly show you kubectl get parts command, that would show me first of all NCache server parts, because those are two parts that are going to have NCache server-side deployment. You can see we have NCache parts with these IDs, and we also have IPs assigned to these as well. They're running, and first part is running with 10.244.1.4 IP, and then we also have the second part with .0.9 IP. I would also show you the kubectl get services. You can just say svc, and that would bring down all the services that we've created. So we have cache server, which is a headless service, and then we also have the gateway, which also has an IP address, which allows us to actually monitor and manage our NCache parts with the help of port mapping from outside world. So 8251, you can see, is actually open for this as well. And the cache server is showing no IP. That is essentially a headless service for client applications to connect to the cache cluster. So we're using this external IP. I should be able to log into the management console. So I'm launching our web-based management tool using this 8251. I think there is, let me just change it, 8250. Yeah, there you go. So I'm logged into this management tool. And as a matter of fact, I'm connected to 10.244.0.9 server. And this ensures that actually our services are fully functional. We're able to actually monitor and manage NCache since we're able to open the management tool from my machine. Next step is to actually get started with cache cluster creation. So we'll review that. At this point, all of our deployments are completed. We can now go ahead and create our NCache cache cluster next. I will now create a cache cluster by clicking on New. That would open the cache creation wizard. I would just name my cache cluster Demo Cache. Keep everything default here. First IP is automatically suggested. And second IP is something that I can pick from here, 1.4. Bring it back here. And then I should be able to add this as well. And hitting next would go ahead and give me some more parameters. Keep everything default. And that's it. My cache cluster is now created. If I click on view details, I can see that it's fully created. So I'm going to go ahead and start this cache cluster on both parts. And that would start my cache cluster. And you can see the status message has displayed that cluster is fully functional and started as well. I can now open monitoring tool, which is again a web-based monitoring tool for NCache that will allow me to monitor my servers as well as clients. And it shows fully connected between these two parts. That's the fully connected status. So I'm good to go as far as cluster creation is concerned. There are a bunch of parameters. No client application is connected at this point, but we can actually run that once we deploy and run the client application. Next step is to deploy and run client applications to connect to our cache cluster in AKS. Okay, now we need to deploy the client deployment as well. And for that, I have another container which I will deploy. And it is a single client container which has both Java and .NET Core client applications bundled into it. So I'm going to go ahead and load client.yml file. And as soon as this deployment is created, I would have my two applications which are going to be ready to be used against my cache cluster. In order to verify whether these are, being deployed properly, I would first of all run kubectl get parts command, and that would show me the container is being created, right? So current status is, and I can see an additional container. So that's a good start. So my client-side deployment is underway. And if you remember, we ran this command previously as well, the kubectl get parts. Previously, we only had NCache deployments, 2 parts in there. But now we have an additional part under client deployment, and it has its own set of parameters, and some IPs would be assigned to it. So if I run this one more time, it's fully functional running. and it has its own IP assigned to it with the specific ID right here. Now, in order to run the client applications to connect to this cache cluster, I would run kubectl exec, provide the ID of this pod, and then I would go into directory right here, apps, app-tester, and I'm first going to run the .NET Core client, and I would run .sh script that would allow me to spin a .NET Core application that would connect to my cache cluster. I additionally need the name of the cache, demo cache, and then I also need the cache discovery service, which was cache server. That would allow me to discover and connect to all the pods within NCache deployment. And that's a feature within NCache client that automatically connects to all the pods if you just specify this discovery service. So my demo cache has been initialized. If I come back to the monitoring tool, I should see some parameters, some performance matrices. One client is fully connected to .9 and to .4 as well, and we have requests per second, average microsecond per cache operation, addition, fetches, and updates on all counters are showing activity. And we have a client process now showing up, which is 1.5, and that's the IP of our client pod, which is connected to both servers, .9 as well as to .4. So that shows that our client application container and .NET Core application is fully able to connect to our cache cluster. Let's run the Java application. For that, I just need to change .NET to Java and run it. So that would just run another script within that, and that would run NCache tester.jar file. So that's a Java file that is going to connect and start performing create, read, and update, delete operations. So CRUD operations are being performed at the moment. So if I come back to the monitoring again, I now have two client processes. We see four because there are two servers. So each client process makes connections to all servers. But you have two clients running against our cache cluster, and there are two pods within the cache cluster. And we have some more advanced, report dashboards, such as server-side report view that shows me server-side counters, replicas from both pods. And then we also have the client report showing the client-side counters as well. So within AKS, we're able to fully manage and monitor our client as well as server deployments without any issues. Next thing that I will demonstrate is scaling out your NCache cache cluster in AKS platform. This will help you increase your request handling capacity for NCache, and that too at runtime. Let's see all the steps involved here. Now, in order to scale from 2 nodes to 3 nodes, and that too at runtime without stopping the cache cluster in AKS or stopping the client applications, we can simply go ahead and demonstrate this. So first of all, I would show you the current deployment. Let's see the current pods that we have. And if you notice, we have 2 pods in NCache deployment, .4 and .9 IP addresses. And then I would need to run this command here where I set the replica count to 3 and do it for deployment NCache, and that should automatically spin a new pod and add it to NCache deployment. I think there is a typo, so let me just run this by fixing it, deployment, and that has worked. So NCache deployment has scaled. Now we have 3 pods within NCache deployment. So if I run the same command again, I should now see an additional pod within NCache deployment. So previously we had 2 deployments for NCache, .4 and .9, and now we have a 3rd pod added. In addition to .4, .9, we have .6 as well. So that's our 3rd added pod, which is now fully functional. And notice we did not stop the application or the cache itself. Now I just need to add this pod to be part of NCache cache cluster. So it was deployed in AKS. I would add it here, and then I would go ahead and start to join the cache cluster, and this will be done at runtime. So without any delays, it would join the running cache cluster and is fully functional as well. If I quickly come back to the monitoring tool, you would now see a 3rd node joined at runtime. So .6 is now fully joined. It has all the data. You can see the count, and then all the requests are fully distributed to 3 nodes instead of 2. And you can also see the cluster status. .6 is fully connected with 2 clients connected to it as well. And we have counters now showing for 3 servers instead of 2. And client processes are again now connected to all three servers, to .6, to .4, to .9 as well. So that completes the auto scaling part for AKS, where you can add pods at runtime, and you don't have to stop the cache or any of the clients which are connected to it. Everything is done at runtime. This brings us to the end of our video. We have successfully demonstrated how you can deploy NCache in AKS platform, and how easy it is to use NCache from within your Java and .NET Core applications. We also reviewed how effectively you can manage and monitor your NCache deployments in AKS. I hope this was helpful. Please share your feedback or questions with us at Alachi Soft Support. Thank you.